Every time you order food online, book a cab, or check the weather, an API is working behind the scenes. Yet many developers use APIs every single day without truly understanding what they are. In this video, we will break down what an API is, why it exists, and how it actually works in a way that beginners can understand and developers can confidently build on. What is an API? API stands for Application Programming Interface. That might sound complex, but don't worry, it's not. The most important word here is interface, something that allows two systems to talk to each other in a controlled way. Let's understand APIs using restaurant analogy. When you walk into a restaurant, you don't go straight into the kitchen to order food. Instead, you ask the waiter for the menu, check what's available, tell the waiter what you want. The waiter then goes to the kitchen and brings back your food. You don't need to know how the food is cooked, what ingredients are used, or how the kitchen works internally. You just order and trust the waiter. Here, the waiter acts as an API between you, the customer, and the kitchen, the server. In software terms, the app is the customer, the API is the waiter, the server is the kitchen. The app never directly touches the database or internal logic. Everything goes through the API. So why do we need APIs in the first place? Without APIs, applications would directly access the database and internal systems. That would make systems insecure, hard to maintain, and easy to break. APIs act as a control layer in between. They create structure, security, and consistency across systems. But that's not the only reason APIs are essential in modern software. APIs enable interoperability, allowing completely different systems to work together seamlessly. For example, when you use Google Maps inside a food delivery app, that app didn't build maps from scratch. It uses Maps API to fetch location data, routes, and distance, all through APIs. APIs improve efficiency by letting developers reuse powerful services instead of rebuilding everything from scratch. And most importantly, APIs drive innovation by exposing data and functionality that others can build on. At its core, an API does just one thing. It receives a request and returns a response. Usually, this data is exchanged in formats like JSON or XML. The app doesn't know how the server works internally. It only knows what to ask for and what kind of response to expect. For example, when an app requests user details, it sends requests to an endpoint. In this case, get user with ID 1. The API processes the request and responds with a structured data. No UI, no design, just clean data. There are many types of APIs. REST APIs are the most commonly used APIs in web and mobile development. SOAP APIs are more complex and XML-based APIs. GraphQL APIs provide flexible querying and data fetching. gRPC used in high-performance systems. In most real-world applications today, REST APIs dominate. As a developer, APIs completely change how you build software. You write backend logic once and reuse it across web apps, mobile apps, and third-party integrations. APIs make systems easier to scale, easier to test, easier to secure. They also reduce development time by allowing you to integrate ready-to-use functionality instead of rebuilding everything yourself. APIs aren't just a backend concept. They shape how modern developers work. One common mistake is thinking APIs are just backend code. APIs are actually contracts, rules that define what can be accessed, how it can be accessed, and who can access it. Breaking this contract leads to bugs or even security breaches. At this point, beginners often ask, so is an API just a URL? No, not exactly. The URL is just one part of the API contract. Whether you are a front-end developer, a back-end engineer, or a mobile developer, understanding APIs deeply is no longer optional. Now that you understand what an API is, The next question is, why does API security matter so much? In the next video, we will see why insecure APIs are one of the biggest risks in modern applications. If you found this video helpful, let us know in the comments. And don't forget to subscribe for the next part in the series. Thanks for watching.